Howdy everybody. Today's tutorial we're going to be going over how to set up grab and throw capabilities. As a demonstration here I have three size different blocks, bigger heavier ones, kind of medium, kind of heavy ones, and smaller light ones. So I'm just going to go ahead and reach over, give it a throw, grab one of the smaller ones but not the smallest, give it a throw. And then pick up the lightest one and give that one a throw. Okay, so to see how I accomplish this, join me back in Unity and we'll get started. So before we write any code, I want to run through the input controller script real quick. On the branch provided for the start of this tutorial video, you'll see that I've gone ahead and filled out a lot of the common bindings that you'd expect. A difference from last video though is I added a cancel notify for both the grip and trigger. And if we just scroll down through, we can see that I default all of the lists just like we did in the last video. I added separate register functions for every possible notify, and then down below I added the performed callbacks for each action, and then for both the grip and the trigger I added a canceled callback instead of a performed callback to let the game know when the user has let go of a button. This will be handy for determining when the user has let go of whatever they're grabbing. So to actually start working on our grab feature, I'm going to make a subfolder under VR by right-clicking, add, new folder. I'm going to call this folder grabbing. And inside of this folder, I'm going to right-click, add, new item, select class, and I'm going to name mine Grab Manager. I'll clean up the namespace. I'll make it public, and I'm going to inherit from auto behavior. Currently Visual Studio doesn't know what mono behavior is, so I'll either right click or hit Control period and select using Unity Engine. At the top of the Grab Manager class, I'm going to add a few serialized fields, one a hand input, a float for grab radius, and a layer mask for the grab layer. I'm also going to add two public vector3 properties, one for velocity and the other for angular velocity. Later on, when we're actually implementing our throw functionality, we'll use these to help make the throw possible. You'll want to note here that the two properties have public gets but private sets. We only want the actual grab manager to be internally setting velocity and angular velocity. Next, I'm going to add a start method, and I'll add 4 input bindings to our input controller: register grip triggered notify, register grip canceled notify, register device velocity, and register device angular velocity. And I'll go ahead and create those stub methods as well. Starting with our handle grip triggered method, we'll need to perform an overlap check and get all the collisions that occurred. Once we have that collision, we'll want to iterate over each collision, find the closest one, and perform our actual grab on that grabbable, creating a method that takes the grabbable as a parameter named performGrab. So here at the top line, I do a physics.overlapSphere, passing in the actual grab manager's transform.position, which will equal our hand's position, the grab radius variable we defined up above, and our grab layer, which should help ensure that we only check against anything that's on the layer that can't be grabbed. I also define a grabbable tested grabbable and a float equal to the float.positiveInfinity. I'll explain why in a little bit below, but we notice here that we haven't made our grabbable class, so Visual Studio isn't quite happy with us. We'll take care of that in a few minutes though. We then iterate over all of our collisions, checking the distance from that collision to our current position. I use square magnitude since it's more efficient and we aren't really concerned with the actual distance. We are just concerned which one is closer. We then check to see if our test distance is less than distance, which is where the float.positiveInfinity assignment comes in. And that ensures that the first one will always essentially pass. And as long as test distance is, then we grab the grabbable off of this current collision. And then we also assign distance to test distance. Up next, to make the Grab Manager class happy, I'm going to come over, right-click the grabbing folder, add new item, make sure class is selected, and I'm going to name mine grabbable, add. I'll clean up the namespace as usual, br.grabbing. I'm going to make this public and inherit mono behavior as well. The grabbable class will actually be really simple, so we can just go ahead and fill it out now. At the top, I'm going to add two serialized fields that are both Unity events, one called onGrabbed and one called onLetGo. If you aren't familiar with them, Unity events are a handy way to be able to make calls out into other code, specifically allowing designers to link up events to this event being executed. For example, maybe we want a sound effect to play when an item is grabbed. We have a small class that can play a sound, and we can wire the grabbables onGrabbed up to it so that onGrabbed it'll invoke whatever play method is set up. Anyway, I'm also going to add a public grab manager property called ActiveGrabber with a public get and private set just like before, and two methods, one named grab, taking a grab manager, and the other named letGo. For our grab method, I'm going to start with an if check on ActiveGrabber, and if it isn't null, I'm going to call a function on it called lost control of grabbable, passing in this. We'll head back to the Grab Manager class in a minute, but I'm adding it here so that if we end up grabbing something with our right hand and then grab it with our left hand, our right hand knows that whatever it had control of is now lost. So we can clean up our references without actually calling any letGo functionality. After that check, we'll just assign ActiveGrabber and call invoke on the onGrabbed event. Our letGo method is even easier. We just invoke our letGo event and then set the ActiveGrabber to null. The order of operations in both of these methods is very important, since the extra layer of features we're going to be adding on top of everything will rely on having ActiveGrabber set and unset at specific times. Now, back in our Grab Manager class, our references to grabbable should be satisfied, and we can work on the actual perform grab method. Just below our handle grip triggered, I'll add a private void perform grab, taking in a grabbable. I'll start by checking if we're somehow grabbing the thing that we're already grabbing just early on immediately. Then also check if we're somehow grabbing something that we're already grabbing something else, and if we all call our current ActiveGrabbables letGo method. And after that, assign ActiveGrabbable to this grabbable and call its grab method with this as our parameter. And now I'll need to define our ActiveGrabbable parameter at the top of the class. Handle grip canceled is actually a lot simpler. We can start by making sure that ActiveGrabbable isn't null, and as long as it isn't, we can call its letGo method and assign null to our ActiveGrabbable. Handle velocity and handle angular velocity are even simpler. Inside of handle velocity, we just assign our velocity property to the device velocity, and handle angular velocity, we'll assign our angular velocity property to device angular velocity. Up next, we'll need to add that loss control of grabbable method that we called inside of grabbable. Note, it's a public void. We're not expecting any return. Inside of the method though, we can just check to see if active grabbable is grabbable. Just reset active grabbable to null. We specifically check if active grabbable is our grabbable because if for some reason anything got mixed up and the grabbable we're losing control of isn't the actual thing that we're grabbing currently, we don't want to replace our active grabbable reference with null. Alright, so at this state, we have a grab manager that should be able to detect when things on the grab layer are overlapped, find the closest one, and then tell it that we've grabbed it. If we let go of our grab button, it should also signal to the grabbable that it has been let go. Unfortunately, even if we set all this up in Unity currently, grabbing wouldn't actually do anything. For that, we're going to need to create a series of what I call grab features. We'll start by right-clicking on the grabbing folder, add new folder, and I'll be calling this grab features. Inside, we'll start by making a new class called grab feature by right-clicking grab features, add new item, make sure class is selected, and name it grab feature. And go ahead and click add. With this class open, I'm going to clean up the namespace as usual, so it just reads vr.grabbing.grabFeatures. I'll also make this a public abstract class and make it inherit mono behavior. I'm making grab feature an abstract class because it by its own won't actually provide any functionality. It will just have common functionality that all future grab features will end up needing. Inside the class, I'm going to start with something a bit different. I'm going to make a serialized field, but a property, for a grabbable called grabbable. It will be protected with a private setter. Since it has the serialized field attribute, we'll be able to assign a value to it from the editor, but from within code, only this class will be able to set its value. I'm also going to make a public bool property called isGrabbed with a get and private set as well. You can see here on the serialized field that it actually has field : prepended. This was what allows Unity to actually display this property in the editor. Grab feature will end up being a pretty core class, so it'll have quite a few virtual functions for inherited versions of it to provide additional functionality. I'll start by adding a private void start and a protected virtual handle start method, as well as a private void update method and a protected virtual void handle update method. Our update method will be pretty simple. It's just going to call handle update. Our start function, however, is going to be a bit more complicated. In start, I'll check if grabbable was not assigned a value at edit time. It will attempt to assign it by finding the grabbable on itself. Then we check if it's null again, and in case we had to check for it on ourselves, and if it isn't null, call register grab feature on it, taking this as a parameter on the grabbable. We haven't made this method yet, so Visual Studio is going to complain, but we'll come back and add it once we finish out this class. After that, we can call handle start. Handle start will remain empty as it's intended to be overridden by children classes to provide new functionality. The benefit to doing it this way, with checking if grabbable is null and start and trying to find it on itself, is it allows us to avoid having to manually link up a ton of references in code, and also provides the designer the ability to specify a grabbable that isn't necessarily attached to the grab feature, or vice versa. Next, I'm going to add a public void onGrabbed and a protected virtual void handleGrabbed, and a public void onLetGo and a protected virtual void handleLetGo method. In onGrabbed, I set isGrabbed to true and call handleGrabbed. HandleGrabbed will remain empty, and on letGo, I set isGrabbed to false and call handleLetGo. HandleGrabbed and handleLetGo are two key hooks that will allow our grab features to provide additional functionality in the future. Now we can go back to Grabbable, and down towards the bottom below letGo, we can add our register grab feature method and hook those up to the events. This is another handy time-saving feature. It allows us to be able to automatically bind any grab features that are associated with the grabbable without having to link them up manually, but still provide the designer the ability to hook things up through the Unity events on the editor side. As a quick example, maybe we have an item that when picked up, it'll snap to the player's hand, but also cause a door to close or open, or play sounds, or trigger any other kind of functionality within the level. The grab feature will manage snapping it to the player's hand, but the designer can then link up any additional calls to the onGrabbed event so that they can dictate what happens. Now that we have our core grab feature set up, we can right-click our grab features folder, add, new item, make sure class is selected, and I'm going to start by adding a snap to hand grab feature. Go ahead and add the class. Update the namespace. Make this class public and make it inherit grab feature instead of mono behavior. Snap to hand is actually a very simple feature. We'll override handle update, check if isGrabbed is true. When it is, we'll set our transform.position and transform.rotation to our grabbables active grabber position and rotation respectively. And that'll be it for our snap to hand. The next feature that we're going to add is going to be the physics grab feature. So right click, add, new item, select class, and now I'm naming it physics grab feature. I'll clean up the namespace, make it public, and inherit grab feature as well. Physics grab features are a little bit more complicated than snap to hand. I'm going to start by adding two serialized fields at the top, one for a rigid body and one for a float called throw speed multiplier. For throw speed multiplier, I'm going to default this value to 1, so that essentially whatever velocity is passed in is the velocity applied to the actual object itself. Next, I'll override the handle start, check if rigid body is null. If it is, try to assign it by getting component on the current object and see if it has one there. This is very similar to what the base grab feature does when it attempts to locate the grabbable. Up next, I'm going to override the handle grabbed method and set our rigid body is kinematic to true and rigid body use gravity to false. After that, we can set up our handle let go, which will basically invert those and set is kinematic to false and use gravity to true, and we'll also handle our throwing functionality there as well. For our throw functionality, we'll be assigning our rigid body velocity, our grabbables active grabber's velocity, multiplied by our throw speed multiplier, and our rigid body dot angular velocity to our grabbable active grabber's angular velocity. With this class finished, that should handle all of our grab functionality for our VR controllers. Next, we'll go into Unity, let everything compile, build a small test level and set up our grab mono behaviors on our VR controllers and set up some simple throwable grabbables. Okay, with Unity compiled, I've added a VR folder in our main assets folder. Inside of that there's a prefabs folder, and you should have a VR controller and a VR rig. On the VR controller, I'm going to go ahead, add component, grab manager. It'll default in my case to the right hand, a 0 grab radius with no grab layer. Grab radius, after doing some personal testing, I'll go ahead and do 0.1. And for our grab layer, we don't have any grab layers specifically set up, so instead we can come up here to layers, edit layers. That should bring up our tags and layers in the inspector. I can expand out layers, and just here on layer 6, I'm going to set up grabbables. I'll go ahead and save, select my VR controller prefab again, and now I can scroll down and instead of nothing, assign it to that new grabbables layer that we made. Now, I can also select the VR rig prefab, go ahead and click open prefab. I have my right hand and my left hand. My right hand should have the grab manager set up just like we did before, right? Grab radius of 0.1, grab layer, grabbables. I can select the left hand, come down and switch right to left. Go ahead and save, and then go back to the scenes. Speaking of scenes, I'm going to create a new one called Playground. I'll delete the main camera and drag the VR rig prefab into the scene. Now I'm also going to set up a new cube game object. I'll scale it out to make a nice floor. With its scale at y equals 1, I set its y position to -½ That way the top of the cube is flush with the floor. Now I'm also going to add another cube, and I'll scale it appropriately to be mostly table sized. In my case, I set its y position to 0.35, pulled it forward a bit, about 1.15 meters, set its x scale to 2, its y scale to 0.7, and its z scale to 1. This way it's flush with the floor and about desk height for me. I also renamed it to table, and I'll rename the cube for the floor to floor. Now we can make our actual first grabbable. Create a new object called grabbable. I'll right click it, add 3D object, assign a cube. For the cube itself, I'm going to set it to a scale of 0.05 on all axes. I'm also going to now come back, select grabbable, hold shift and control, and now you can drag the manipulator and that'll snap it to a surface. I can come in. On the cube, I'll actually set its y position to 0.25, so it's flush with the table. Next, on the actual grabbable named object, I can add component, add grabbable. I can add the snap to hand and the physics grab feature. Physics grab feature is expecting a rigid body, so I'll go ahead and add that as well. The last thing to do is go ahead on our grabbable cube and set the layer to grabbables. That way our physics can know that it is on the grabbable layer when it does its overlap. And we should be able to hit play and see it work. Okay, real quick. While testing this out, I did realize that I had made a typo. Active grabbable should be a double equals to check equality. And now we should be able to hit play and actually see our grab functionality work. Okay, so we have a grabbable that we could pick up and throw. Next, I'm going to create a duplicate of this grabbable. I'll move it off to the side. I do plan on scaling it up a bit more, something like 0.075. Its Y position will now be half of that scale. And then I'll duplicate it one more time, scale it up to 0.1, its Y position to 0.05. I'm going to go ahead and grab them, move them over a little bit. On our smallest grabbable, I'm going to set its throw speed multiplier to 3, the middle size grabbable throw speed multiplier of 2, and the big one leaving it at a 1. Now we can go ahead and hit play and see how the throw speed multiplier affects our throwing. One more quick thing I'll do is I'm going to go back to my VR prefabs on my controller, open the prefab, and I'm going to disable the collider on the hand for now just to make sure that it doesn't cause any weird interactions with our throwing. There we go. Okay, that should wrap it up for having our ability to grab and throw objects. Hopefully the system that's in place now kind of inspires you to think of new things that you can add to the grabbables. Next tutorial we'll be working on guns, both pistols and rifles, so that we have one-handed and two-handed weapons, and some basic damage setup so that we can go ahead and create a little target shooting range. Thanks for watching. Please like, subscribe, and comment below if you enjoyed the video, and I'll see you guys next time. Bye.